There's no justification for that. What they are doing is they are saying, which is true, you can make the basically your point of reference anywhere you'd like, because that is the cosmological principle. No place in space is preferential to anywhere else.
But that let's just fully acknowledge that that worldview was created after we did observations, and all the observations came back that we were the center. Then we had to come up with the idea of why this would be without assigning us a special place in the universe. And this shouldn't even be debatable, right? This is exactly what Hubble was talking about when it said we must avoid the special place in the universe, and it would only be welcomed as a as like the very last ditch thing to explain an observation. Only then would we accept that as the observation. Until then, if we can come up with some BS to explain it, we will go with that route.
Yes, I like the language you all use. So
Well, for all intents and purposes, relativity essentially was that BS made to explain away observations.
I don't know what you mean by, so you made the assertion that all of the observations we have made point to the fact that the Earth is the center of the universe. That's, I don't know what observations you're saying, and if honestly, if you're going to say Michelson-Morley, then you truly misunderstand what that looks like.
No, that's just the one that tells that we're not moving through the ether.
Okay. Well, as far as I know, there is no experiments that showed that the Earth was the center of the universe.
All of them show that. That's why Stephen Hawking literally wrote a book on it called The Persistent Illusion, or it's something like that. You can look it up. Basically, all the observations, including the microwave, radio microwave background, all tell us that we have a special, unique position in the universe, and that we're
the CMB does not do that. The CMB, there is something called the axis of evil. Yeah, and
why
again,
is it called the axis of evil?
You're laughing at me.
But why is it called the axis of evil?
It's because it's a play on word. It's play on words. I have no idea exactly where it comes from. I know it's a relationship to.
It's called the axis of evil.
Bush.
It was called the axis of evil because, again, noting back to Hubble, that we have to avoid the special position, the unique position in the universe at all cost, and this axis of evil directly indicates that we are in a special and unique position in the universe. That's literally why it's called the axis of evil.
No, it's called the axis of evil because, well, it may be so, but specifically, it's called the axis of evil because it's referencing George W. Bush's thing about Iran, North Korea, and what have you.
But why is it referencing that?
I'm not sure.
You can
but
just,
I can tell
we
you
can just
what
admit that it was exactly what I said, and that it's a little uncomfortable for your position.
I do not know what this is what I will say. I don't know why it was called the axis of evil. What I will say is that, yes, it is something which is contrary to the cosmological principle. But what I will also say is, can you explain to me what the axis of evil observations are?
Yeah, so there's sections of hot and cold. They form a dipole, and then when you extend that out, it's actually a quadrupole, and they all line when you wrap it around a sphere, it lines up to where the Earth is basically right in the intersection point of all of that.
Okay. Does all of the analysis show that?
Yeah, in fact, they're still trying to disprove it. They haven't been able to.
Correct.
They haven't been able to do it yet.
That's not correct. They did a dipole, a quadrupole, octopole, all the way out to 1024. The only two, from my understanding, the only two that actually show that there is any kind of effect are the quadrupole and the octopole. Most of the data, most of the statistical analysis in this realm illustrates that there is no axis of evil. I can send you a paper that critiques this and gives 6 or 7 reasons for why this particular anomaly exists. But to say that the axis of evil proves that we are in the center of the universe is a misrepresentation, because that's not what the axis of evil states. So,
well, I'd be open to seeing that information, seeing that paper.
Okay.
Again, because for you to simply say, well, that's not what the axis of evil states, that would just fly in the face of the whole reason why it was called axis of evil in the first place. So maybe again, I'm not up to date with all the information, and maybe they have come out with more to be able to debunk that. I don't know. I'm open to seeing the information. Definitely interesting.
Okay. I'm not saying that the axis of evil doesn't exist. That phenomenon does exist. There does seem to be some kind of evidence pointing that the anisotropy in the CMB is present in the octopole moment and the quadrupole moment, and that, from my understanding, can be seen in all three maps. But those are the only moments that occurs. I've heard that it's in the dipole moment. I would need to confirm that, but I can assure you that what the evidence says is that it's seen nowhere else. In the higher modes, it's not seen at all. It's completely isotropic.
Well, I definitely would like to see that. Jim, you have anything you'd like to add?
Sure. Astrophysicist Askoff, Ashok, K, Singal, Singal, said, and I quote, the apparent alignment in the cosmic microwave background in one particular direction through space is called, quote, evil, because it undermines our ideas about the standard cosmological model. The Copernican principle seems to be in jeopardy. You have an astrophysicist who says it's evil to think that we're in the center of the universe. Then there's a lot of quotes, I'm just going to use two. Then we have George Wald, Nobel Prize winner, Origin of Life, Scientific American, August 1954. And I would like to get your opinion on this as a man of God, Professor Parks. When it comes to the origin of life, we have only two possibilities as to how life arose. One is spontaneous generation arising to evolution. The other is a supernatural creative act of God. There is no third possibility. Spontaneous generation was scientifically disproved 100 years ago by Louis Pasteur, Spallanzani, Redi, and others. That leads us scientifically to only one possible conclusion, that life arose as a supernatural creative act of God. I will not accept that philosophically because I do not want to believe in God. Therefore, I choose to believe in that which I know is scientifically impossible, spontaneous generation arising to evolution. Now, this is where you don't have to be a biblical cosmologist to you can keep God and the Bible out of it. But this is the problem that we have, is that 90% of physicists are self-described atheists, and it's amazing that, of course, the world's not going to respect it. It's not going to acknowledge that because the world tends to be atheist anyway. So, do you have an opinion?
Jim, that's poisoning the well.
Do you have an opinion, Professor Parks, about what George Wald said?
Sure, but let me, as a general rule, I don't give credence to quotes. Einstein said whatever to Mach. This dude said whatever. Newton said whatever to whoever. I really don't care. The reason why I say that is because I am more interested in what the science tells me. I'm more interested in how what relativity says, what its predictions are, and whether or not we can verify them. In terms of Wald makes a blunder, actually the same kind of blunder that Einstein made, in that Einstein could never accept that quantum mechanics was a thing. He let his worldview, his spiritual worldview, you can argue whether or not Einstein was an atheist or what have you, but he certainly had a philosophical worldview at the very least that told him that that the universe must have been deterministic, that in fact that there is no chaos whatsoever. It seems to me that Wald is also taking a point of view. If I remember correctly, he is an atheist.
Well, he doesn't want to believe in God.
He doesn't want to believe in God, so he is biasing his scientific integrity by bringing in a metaphysical question. And that is a problem. It shouldn't matter, or doesn't matter, whether or not I believe in God, whether or not another scientist believes in God, if the science tells us this is to be true, or if the science tells us that this is the best possible explanation, that the universe is 13.7 billion years old, then as a scientist, that's what I accept. As a Christian, what I accept is that I have no comprehension of God's ability. God is infinite, all knowing, and all wise. So I am left with the result of saying, okay, well, God created it to be 13.8 billion years old because that's how God wanted it. So to me, bringing in your spiritual worldview in context of scientific inquiry should not be done. It is bad.
You mentioned, Professor Parks, science tells us, a couple times in the last couple minutes. Science tells us, Professor Parks, that the Hubble law, or the Hubble constant, says that we are an ever-expanding universe. That you would agree with that the universe is expanding at 73.3 kilometers per second per megaparsec. Megaparsec is 3.26 million light years. You can do the math. The speed of light in your world, fairy tale, is 186,200 miles per second. In the ever-expanding universe, redshift, it is expanding at 400 times the speed of light. 400 times the speed of light of 186,200 miles per second. Do you agree with that?
I think you're talking about the inflationary period, and basically it is not expanding past the speed of light because essentially the fabric, the fabric upon which the fabric of the universe is itself expanding, and so to say that it is expanding faster than the speed of light is sort of apples to oranges comparison. It's not a fair comparison. Now, I will again admit that I don't have a very good at the moment. I don't have a very good explanation to explain that very well, but it is something that I plan on addressing at some point. But the idea is that idea that we are that thing was expanding at such a high rate, faster than the speed of light, would involve us being outside of the universe itself, which is not possible. So that's the best I can do.
A lot of what we're talking about tonight doesn't seem possible. I do want to pass the floor over to F'd Up World, who had a specific question, wanted to talk specifically about stellar parallax, and I couldn't read the rest of it, I forgot it, I should say.
Just measurements.
Yeah, Joe, go ahead.
So, Rob Parks, you were saying is that it's like an observatory that you have access to, or that you work for? Mm-hmm. And do you guys do stellar parallax measurements from there, or not really?
Not at our institution.
Okay.
The place that I got my PhD from, there was a sub department they did. Then they were dedicated to it.
Okay, and I can agree with a lot what you're saying about if science says something, but then that's going to be the truth usually, or it should be the truth. But if there's flaws in how we do the science, that's what would be where I would point it. So just to put it in a nutshell, tell me what you think of just this. And my understanding might be wrong about stellar parallax measurements, but you need typically 6 months. You make measurements 6 months apart or so.
No, you make almost continual measurements over a span of years.
Okay, but you're comparing when you're on one side of the sun to when you're on the other side of the sun, right?
In a textbook way, that is how stellar parallax is done.
Okay.
In actuality, stellar parallax is done by looking at a particular field of star, or looking at a particular star and observing that over many years, and then
Mhm.
looking at the path of that star as it goes across the sky in that field over the course of a year or so.
Okay. But do you have is there the I would point out an assumption being made that the Earth, where your observatory or that you're measuring it from, is moving, 186 million miles or whatever, but the parking lot's still in the same spot. You know what I'm saying? The observatory didn't move. It seems like an assumption to me, or it would include that we're orbiting the sun, right? It would have to. I mean,
The best explanation that we have is, and this kind of goes to a point that Tribune made before, is you don't need to come up, well, the explanation that we have for trigonometric parallax is that the Earth is moving around the sun. Now, if you can come up with a geometry that allows for stellar parallax to exist without the motion of the Earth around the sun, then I'll sit up and take notice.
just the stars moving, isn't it? Just with their moving position, different than they do throughout the night or throughout the year, right? Am I
Yeah, so
correct?
they are moving with relation to the background field of stars.
Yeah, like the fixed stars that are behind it or around it or whatever.
Yeah.
So yeah, I would still say, I'm just these questions always just kind of make me wonder why, if I don't really, what do we use stellar parallax measurements for, really? I mean, just to get distance of stars and things, or
Distance of stars, planets, asteroids.
the sun or whatever.
Well,
I guess
we
I don't
don't
know
use
if you
it.
could yeah, you can do that with the sun.
You
Okay,
can't use
never
it
mind.
for the sun.
Okay. Yeah, I wasn't thinking
Well,
that.
you can use a type of parallax to do it, but it's not the same as stellar parallax. You can observe the sun at two different positions on the Earth simultaneously.
How do we know that though? Like, I mean, well, I think I know what you're saying. The sun rises in the east and sets in the west, though. Everywhere, pretty much.
Sure.
Yeah, that's what we actually observe.
Yeah.
When I think of the solar system, I think of like this dark place where you see the sun and then you see these planets on their orbits going around, kind of in a one after the other or whatever. And every time I think of that, my vantage point is in a place that doesn't necessarily even exist. Like in when I picture that in my mind, I'm looking from this place out in space or something, and I'm like, the solar system to me, I don't think the Earth is part of it. I think there is a solar system. Like if you're looking through a telescope, and I do this for maybe 10 years. I've had some telescopes and I spent some time doing it, but I think we do see, I don't know if it was 5 years ago or something. I filmed Mercury transiting the sun. It was between my camera and the sun, and I watched it. I don't know if it took a couple hours, I think. But if you film it or take pictures of it or just note its location, throughout time, you will see a solar system up in the sky. But my argument would be that the ground beneath our feet isn't necessarily part of that system. That's a system that's in the sky, and the Earth that's like part of the Earth's sky, if that makes any sense.
Sure.
I'd like to take a second to welcome Robert Hunt to the show. He is a frequent listener and, from what I can tell, a Globe zealot, which is awesome. He actually offers a ton of corrections in the comments, so I thought he would be great to have him come on up. Welcome to the show.
Hello. This is my first time on any stream, so I just downloaded Zoom, and it seems to be working.
You managed to go through the entire pandemic without installing Zoom?
Actually, I had Zoom before. This is a new phone, so I did do a couple of family Zoom calls, but I wasn't working remotely. I'm actually a professional stargazer.
Really?
Welcome, Bob. Welcome, Bob.
in telescopes. I'm very interested in astronomy. I am not an astronomer, but I do a hell of a lot of telescoping. And for instance, when you were asking before, if you can take a picture of what you're seeing, absolutely. I do it all the time. It's called digiscoping. You can take your eye away from, it works better with solar system objects, but you can take a regular cell phone and take a picture of Jupiter, Jupiter's the moons, the shadow of Jupiter's moons on the ball.
Yeah.
Extremely high fidelity. Be very hard to fake. Very hard to pretend that it's some conspiracy where Samsung is filling in the details or anything like that. The sky is out there. NASA does not have a monopoly on it. There was astronomy being done, really high level astronomy done for hundreds of years, really, before there was any computers. Even photographic techniques were completely analog, emulsion based the first 70 or 80 years. So you don't have to wait for NASA to give you the truth.
Robert, I'd like to come back to that in a second.
Can I ask a real quick question?
Tribune myself.
Why'd you call him a zealot?
Actually, it's a term of endearment here. Zealot's actually the top tier of the Tribune membership. So,
got it. Okay.
So that just means that you're really into it to me. But
got it. Okay.
If I could follow up, and then we can get to Robert's point, which I'd love to. Professor Parks, so the audience knows, and I want to see if you agree. When you talk about stellar parallax and distance to the stars, you're talking about 89.999999999999, sometimes out further percent. Is that correct, or am I incorrect?
I'm sorry. What percent?
If you're doing stellar parallax, 6 months and 6 months, and you draw a line straight up to supposedly find out how far that star away is, and your angle at the base, going up and at the horizontal, obviously a 90 degrees is the best you can get for a right angle. Yeah. Will you concede that those numbers are actually 89.999999 or more, and we're supposed to believe that somebody can actually measure the difference between 90 degrees and 89.999999, however far out it goes? I've heard they can sometimes go out, so far it's ridiculous. And so, can you concede that those angles are that extreme, close to 90 degrees right angle? Will you concede that?
Yeah. So we look at it. Astronomers actually flip it, and so when we look at the parallactic angle, we're talking about typically the parallaxes that I've dealt with. You're talking about milli-arc seconds. So 1 degree is 60 arc minutes. So to give you a kind of real life physical example, you have the full moon is roughly speaking 30 arc minutes in size. You then take 30 slices of that. That 1 arc minute can be then divided into 60 arc seconds.
Yes.
And then you take one of those arc seconds.
Yes.
And you split it into 1,000 pieces.
Yes.
And your parallactic angle is going to be, that big.
Yes. So
on order to that. Yeah.
So a right angle, at 6 months and 6 months, looking up a right angle to the zenith and to the horizontal would be 90 degrees. And you will concede that those numbers, if you actually put them out, would be 89 point how many nines out, and that close to 90. So it's something that your side uses to prove long distance to the stars, 90 degrees, and you take it to 89.999999999. Who knows how far out it goes, and we're supposed to believe it. Is that correct?
Yes, because we have error bars to illustrate just what the precision is.
Not from your home telescope. You're not going to measure it from your home telescope.
No.
It's interesting that these numbers, like ever expanding universe, time dilation, pound Repka, pound Snyder, Halfley Keating, the atomic clock in Boulder, Colorado versus sea level in the UK, have such astronomically small numbers involved. And if I told you them, you would think that your side, Professor Parks, is nuts. And you just make stuff up so you can prove your time dilation, so you can prove your stellar parallax. I'm telling you guys, these numbers are so small, like Planck's constant and things like that, that they make them so small that you say to yourself, well, they got to be correct because they were measured. You assume that the people doing this work are honest and they don't have an agenda. That is what I want to tell people. So stellar parallax is one thing. Can I go to one other thing before we go back to Robert? Because I have an opinion on what Robert said.
Yeah, but you gotta try not to monologue so much.
Okay,
a lot of floor time.
I'll try to get through this real quick for Professor Parks. Professor Parks, you agree that a bullet, fired over distance, will the Earth will spin underneath it?
It will exhibit, or it will. You need to account for Coriolis.
Okay,
yes.
So Shepard Humphreys, known for the longest shot ever, 7,444 yards, a little over 4.25 miles. It was 24 seconds in the air. He hit an 8-inch bullseye at the 69th shot. It happened September 20th, 2022 in Wyoming. And he basically said to Jaron in an email that in the first line, Coriolis was not taken into effect. Craig Harrison, famous for his 2 kills in Afghanistan from 2,707 yards. He said in a 45-minute video, at the 35-minute mark, the interviewer asked him, "What did you do to make that shot?" He said that about 300 yards, the bullet, stays in a straight line. But after that, we have to lob it. You got, lob it for 2,707 yards.
I'm gonna interrupt you real quick just for this tremendous shout out. I'm gonna go ahead and hold on. Who was this? Lots of memberships. Lord Racer gifting out 5 memberships out to the audience, man. Grab them up. And Nominal gifting out 10 memberships as soon as we got it live. That is absolutely incredible. Much love, guys. Thank you so much for the support. Enjoy.
That is awesome.
Enjoy those custom emotes. We got the Mind Murked, which is just a brain exploding. And we have the True Earth, which is a nice representation of the AE. At least that's my personal opinion, right? Feel free to change my mind. That's why we do the panels, right? Great conversation so far, guys. Sorry to interrupt.
No, it's great that you get that sent to your channel, because you definitely deserve that and a lot more.
Yeah.
So Craig Harrison at the 45-minute video, the interviewer asked him, "What did you do to make that shot?" And at the 35-minute mark, Craig Harrison said, he basically at 300 yards keeps doesn't have to worry about loft. But at 2,707 yards, he had to worry about loft, over the top. Never once talked about Coriolis. And that is on the 45-minute video at the 35-minute mark. And then Eric Haney, Haney, in a 2002 memoir called Inside Delta Force, they had to train themselves to slow their heartbeat down so much that they had to take the shot between their heartbeats. And that's how important it was. And in the memoir, he doesn't mention Coriolis at all. He had to slow their heart rate down so much that they could take the shot between heartbeats. So we have 3 instances of there is no Coriolis whatsoever. No matter what Mark Wahlberg says in the movie Shooter, where he says he has to take into account Coriolis when he's talking to Danny Glover. I think it was Danny Glover. And so we have 3 real life instances here. The longest shot ever, 4.25 miles, the 2 kills that Craig Harrison did, and a book by Eric Haney saying there is no Coriolis effect. We see the target, we shoot the target. Obviously we got bullet spin, obviously we got wind, obviously we got lob and things like that, but there is no spin of the Earth underneath the bullet. And this is why I personally call what not necessarily you, but it's a fairy tale. you get into manuals. The manual is not going to tell you live on a stationary topographical plane and don't worry about the Coriolis. They're going to say it, but when you get out in the real world and have to defend yourself and defend others, there is no Coriolis whatsoever. I'm sorry, Professor Parks. Some of us, and we'll get to Robert and whatever people want to ask Robert, we live in a world that experiences a stationary plane. When we go out in the world, we don't see a ball. We don't see any of that. We see a stationary plane. We don't see 8 inches per mile squared. We don't see the second law of thermodynamics. We definitely don't experience Newton's third law of motion. We don't get into the inverse square law of light. Why we think we can see Saturn and the moon is the same light when we get close to it, quote, to it, like Artemis and Apollo.
I gotta get some music. You gotta start playing you off, Jim.
and I just love it. Anyway, thanks for that little monologue, and Robert, thanks for joining us. Robert, I have questions for you, but other people, go ahead.
The only thing I will comment on that is I've heard other shooters say that they deal with Coriolis in their long distance shooting. Why they didn't, I don't know. I'm not a long distance shooter, so I mean, that's not a viable argument for me because I've heard other people say differently. I again know what the science tells me. Yeah, Coriolis is a thing that needs to be taken into account.
I think science also tells you that you have Hubble redshift, but I think the science is also telling us that the galaxy at Andromeda is experiencing blue shift. Is that correct?
That is correct.
Okay, so then I'll get off. Redshift, the entire ever-expanding universe, but Andromeda is experiencing blue shift. Help me out with that one.
So most of the galaxies in our local group are experiencing are blue shifted in some way. If left to their own devices, the 24 some odd galaxies in the local group will eventually eat each other and form into a single large galaxy. You have two motions. You have what's known as peculiar motion. That is the motion that was produced during the formation process of these galaxies relative to each other. And then you have the Hubble flow, which is the rate at which things are moving away from each other based on the expansion of the universe. On short distance scales, the peculiar motions can be larger than the Hubble flow. But once you get higher and higher, or further and further out, the peculiar motions are never going to be so fast that they are more than the Hubble flow. And so they get essentially averaged out, I guess. They don't contribute as much. And you can actually see that in Hubble's first plot, I think in the 27 paper, where if you look close to where he's at, if you look at the very short distances, there is no linear relationship. It's only once you get out of that out of the local area that you start to see the linear relationship, the Hubble law.
Didn't Hubble say that everything was redshifting?
Real quick, got another 5 memberships gifted from Justin Johnson. Huge shout out, much love. All right, go ahead and address them, Robert, and then I really want to try to give the floor to some more people.
Yeah, to Robert. So didn't Hubble say that everything was redshifting?
He didn't. He would not have said that every galaxy in the universe is redshifted.
Okay. I have Cynthia Phillips, who has a little bit of juice, worked at the JPL, has a little write-up in Wikipedia in the book that she did on Einstein. I have it right. Actually, I have it right here. She does have the part in here. It is a puff piece on Einstein that Hubble did say everything was redshifting.
I think he was being very loose in his terminology when he said everything.
Cool. Well, I think that was part of why they had to come up with the whole raisin bread analogy, right, of the universe and how it looks like you're at the center from all places and that it's expanding from your central location. Because what we observed is that everything was actually expanding away from us instead of having some red shift and some blue shift, as we would expect if something all came from like a big bang or something like that. Instead, we saw red shifting, so they came up with the idea of that again, that everything was expanding from all areas, and that it would look like that no matter where you were, even though we don't have, at least I'm pretty sure we don't have actual viewpoints from other positions in the solar system or even in the galaxy to be able to back up that.
We have observations which illustrate, and I will get you the specifics. We have observations that illustrate that we are living in a isotropic and homogeneous universe. In terms of the redshift, as I just clearly stated, on a local scale, you will have redshift and blue shift due to peculiar motions. When you look at longer scales outside of the local group, those are going to be redshifted galaxies. If there is a galaxy out there that is actually blue shifted, then that is something weird. I can tell you with absolute certain that once you get past probably a megaparsec a gigaparsec, you're going to find no galaxy that is blue shifted, none, because the Hubble flow is so large that it's going to dominate any kind of peculiar motions. So the Raisin Bran example is simply a way of explaining how you have an expanding universe where it's not expanding into anything.
It was going to be my follow-up question too, because I remember being heavily indoctrinated as a child. I watched a lot of like Animal Planet, Discovery, to pass the time. And one of the things that I remember hearing about was that we were on a collision course with the Andromeda Galaxy, and within a couple billion years, eventually we will collide like two specters in the night, and the gravity will get all twisted up, and it might be the end of life as we know it. And then that would be like, well, shoot, if Andromeda's like heading towards us, the evidence of that would be them looking at it, and then it be blue shifting, right? So then that would obviously fly in the face of everything being red shifted. But I do agree with Jim though that it was claimed that everything was red shifting. So yeah, maybe
okay, I'm losing a little bit of patience with that because I've already explained it twice.
No, I agree
if that
with
person
you.
said no. If that person said everything, they're wrong. No astronomer is going to tell you that every galaxy is redshifted. There's no astronomer that's going to tell you that. If they tell you that in that book, it's probably because it's popular science. But I am telling you, as a professional astronomer, that the Andromeda Galaxy is blue shifted. I believe the Triangulum Galaxy is blue shifted. Ultimately, those galaxies are going to collide in and upon themselves. Because the peculiar motion, because the initial momentum of those galaxies once they formed are larger than the Hubble expansion on a small scale.
I'm dying. I'm sorry. I'm dying, Baller Joe. It's freaking killing me, dude.
What?
Yeah, I didn't mean to frustrate you, Professor Rob. I was actually clarifying that I agree it is probably just a more nuanced position. And that I like that you're making the distinction between popular science and real science, because I think that's like a big thing that flat earthers were trying to bring to the table, right? It's like there's the idea of what people think is science. When it doesn't go through the scientific method, it's, for all intents and purposes, just flying by the seat of your pants, pseudoscientific claims built upon each other. That claims to be scientific, and it's taken by the masses as being very, very popular. And then there's the actual scientific method where you observe real phenomena, do your best to isolate a cause and effect relationship by manipulating variables and controls. So yeah, I like that you brought that up. Something earlier that you mentioned as well was that I wanted to bring up but haven't been able to touch on was you mentioned that there was a disagreement between classical mechanics and relativity, correct?
Correct.
Can you go dive in a little bit more into that?
I can, but you want Robert to?
Yeah, sorry. Rob,
how about we table that and let Robert?
You're right. We've been hogging the floor. I invited you on personally, Rob. So,
I would like to get back to aberration and stellar parallax for a minute, because when Jim was talking about decimal points of 89.99999, yes, the distant objects in the universe would have a parallax extremely hard to measure if it could be measured. But parallax was originally measured on the very closest stars to us. I think something in
forgot what
one of the stars in Cygnus.
it was
and,
somewhere in Cygnus, yeah.
And the closest stars are 4 and 8 light years away, and they have a parallax. It's still less than 1 arc second, but it's about 3/4 of an arc second. And those parallaxes were discovered using classical methods in 1820 or thereabouts. And they were looking for parallax 1,000 years earlier and couldn't see it. The Greeks said, well, they must be impossibly far. We can't measure a parallax. And the original parallax was originally discovered, aberration, I should say, was originally discovered when they were looking for parallax. And they discovered these ellipses that you would find in the sky, except they were oriented 90 degrees to what you would find from stellar parallax. And they had a magnitude of about 30 or 40 times greater. They were 20.2 arc seconds, I think. And every star that we can observe anywhere in the galaxy has that same aberration. It can't be, if you talk about this neo-Tychonic model that you extend beyond the solar system, sure, you think you can explain retrograde motion by just saying, oh yeah, they're all doing the daisy of life or whatever, the flower of life that Austin Whitsitt loves to talk about. It's silliness. There's no mechanism that can actually, does the math work out in the neo-Tychonic fashion? Yes. But now you have to add to it every star doing an ellipse in the sky on an annual basis that's oriented 90 degrees from the parallactic ellipses. This is you talk about the Earth spinning around the sun, and the sun is spinning around the universe. The motions I'm describing are far more complicated, and they would happen on every star you can observe, varying from the ecliptic all the way up to the ecliptic pole, where you would see a complete circle, and it wouldn't be an ellipse. So Neo-Tycho doesn't get you anywhere. Tycho knew the Earth was a globe. He just didn't want to admit that it was spinning. But if you say neo-Tychonic and think that you can explain stellar aberration and stellar parallax, you just can't. So I'd love to see it. I'd love to see that paper you've quoted, the neo-Tychonic paper. Look for any mention of aberration. Look for any mention of stars. It's about the solar system. And it's cute math, but it doesn't explain what we see. So
Alpha Centauri is thought to be in your fairy tale is thought to be 4.37 light years away, which is approximately 25 trillion miles. Could you work out the decimals after 89 on that one sometime? You don't have to do it tonight, but could you do
right now? It's could
you do the stellar parallax 89 point blah 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 on 25 light years away?
Yeah.
Excuse me, 25 trillion miles away. I'm sorry.
Well, I'm doing it in light years. And if it's 4 light years, it's going to be 3/4 of an arc second, which means if it's 8 light years, it's going to be 3/8 of an arc second. This is a linear relationship.
What is the 89 point? How many nines do I have to go out to get that?
3, maybe. But
3?
Let me tell you, my telescope resolves 1 arc second beautifully. I get round moons when I image the Galilean moons. So I get round shadows of the Galilean moons on Jupiter. Look at the size of those. Jupiter is 30 arc minutes across, 40 arc seconds across. The shadow of the moon is certainly smaller. The shadow of the Galilean moon is certainly smaller. So my telescope can resolve these. Classical instruments had no trouble getting parallaxes out to about 60 light years. And it wasn't, the period of getting stellar parallaxes was 150 years ago, because within 25 years, all the stars that were close enough had been measured. And they had to wait for Hipparcos, and then later the Gaia satellite. And now I believe the stellar parallax universe, it goes out to about 6,000 light years. So that's the milliarc seconds that you're talking about, or the microarc seconds that you're talking about. But these instruments make these measurements. The stars are very well behaved.
I would like to,
and you can
Relational mechanics. That's what it is.
go ahead.
just very briefly,
Scott.
since both of you are obviously familiar with this debate, I would love to get your guys' opinion on this quote. I know that Rob Parks doesn't really like the quotes too much, but I do like quotes because, again, when we're having these debates, credentials always gets brought up, expertise and all that good stuff. So obviously you guys are probably familiar with George Ellis, famous astronomer, astrophysicist, whichever his title was. I can't remember what it was specifically. Maybe it was both. But he says
prize for discovering the increased expansion of the universe. Basically, confirmation of dark energy is what he got his big prize for.
I suppose that's one interpretation. He actually said that as far as I'm trying to remember the exact quote because I don't want to get accused of misrepresenting.
I got it right here if you want me to read it.
Go for it, Jim. Thank you.
I think this is the quote. You know, tell me if I'm wrong so I don't read the whole thing.
The one from Scientific.
The right one.
Is it the one from Scientific American?
Oh, I got that one. It's not George Ellis, but it's a different one. I don't want to read. Should I? It's not real long. Because I just read what George Ellis says.
Sure.
It says George Ellis says that George F.R. Ellis, I can construct for you a spherically symmetrical universe with Earth at its center, and you cannot disprove it based on observations. You can only exclude it on philosophical grounds. I love the philosophy. In my view, there is absolutely nothing wrong with that. What I want to bring into the open is the fact that we are using philosophical criteria in choosing our models. A lot of cosmology tries to hide that.
Now, what was really important about that is that he didn't just say that there was like, hey, there's another possible model that we could be going with. He says there's a range of models, and I don't disagree. I wouldn't be surprised if there was several different Earth models, spherical and non-spherical, that could explain the observations. Now, the thing that's interesting, though, that he does bring up is that, I mean, it just goes back to the Hubble thing, right? We're choosing to stay away from the idea that we're the center of the universe. But again, our observations could very show that and can be interpreted as such. But we then stretch and try to make up things like one of the big things. I'll just go right into it, right? We know about the Michelson-Morley. It gets heavily misrepresented, I feel, in the scientific community in that, oh, well, this was something that was specifically designed to test for the ether. And I think that that's ridiculous. I mean, I don't think that I won't assume that you guys think that, right? Do you guys believe that the Michelson-Morley experiment was specifically testing for the ether?
I haven't read the paper. From my understanding, it was, but I honestly haven't read the paper. I should at this point. It gets brought up so many damn times.
Here's the article from November 1887, American Journal of Science.
Yeah.
Right there on the relative motion of the Earth and the luminescent ether, and there is so much. I'm not going to read them obviously, but there's about 15 quotes here from your side, Professor Parks, that is really concerned about what Michelson-Morley told us. And then you get the BOGO sale, you get the buy one get one free, the twofer with Michelson Gale Pearson, which your side wants to say prove the rotation of the Earth. No, it proved the sidereal rotation of the sky above us, which translates motion down to the Earth, which can, away from the magnetic north in the southern latitudes, give you a small Coriolis effect that can give you these weather systems that you call hurricanes. It has nothing to do with your fairy tale Coriolis. It has to do with the sidereal rotation of the sky, which translates motion down to the Earth. And that's why no interferometer experiment ever has shown more than 3, 5, 6, or 8 kilometers per second around the sun. And you Google it and it says 30 kilometers per second or 66,600 miles per hour. But no interferometer experiment, Michelson-Morley, Dayton Miller, who did tens of thousands of them because he believed in data, a lot of data. None have showed more than 3, 5, 6, or 8 kilometers per second around the sun. But you got Lorentz in 1892, which gave you Lorentz contraction, which contracted the apparatus of the light going with the motion of the Earth, and it totally ignored the light going perpendicular to it because they had to get their fairy tale 30 kilometers per second. I know that bothers Globers, that bothers, people like that, but that is what Michelson-Morley did, and the Lorentz the Lorentz contraction did. It contracted the apparatus, and it made the light going with the motion of the Earth appear slower than it actually was. My friends, we got you. You don't want to admit it. Your cognitive dissonance, your Stockholm syndrome was great, but we appreciate you being on here anyway and talking with us.
Well, taking a victory lap doesn't really mean that you earned a victory. Einstein wasn't trying to figure out if the Earth was moving. Michelson-Morley wasn't trying to figure out if the Earth was moving. They were trying to measure motion relative to the ether. They couldn't find it.
I have 12 or 15 quotes here.
It's like you don't even understand what that means.
I have 12 or 15 quotes here, Robert, that refute just what you said.
Relative to a fixed ether. They couldn't find one.
Right, which would imply what?
The Earth, they weren't. This was not a scientific debate in 1875 whether the Earth was moving around the sun. They weren't trying to prove from their basement whether the Earth was moving around the sun, because that was scientifically settled by Kepler 250 years before any of that.
No, they were trying to determine the speed. You just said it. They were trying to determine the relative motion of the Earth through the ether.
They were trying to measure motion relative to the ether.
Okay.
Trying to measure the motion of the Earth around the sun relative to the ether, yes. But they were trying to measure it relative to a fixed ether, which they could not find. 4, 6, 8, 10, those are all within the error. You're right. They were trying to find 30 relative to an ether, and they couldn't. So then they started talking about dragging ether, which totally blows the point of the luminiferous ether to begin with. And, if you want to say that the quantum foam is an ether, go ahead, but it doesn't constrain the travel of light in any way. It's not luminiferous. The quantum vacuum is not an ether. It doesn't have the classical ether characteristics that you're looking for. And you say we can't find dark matter because we've been looking for it for 80 years and we can't find it. I don't know what to say about that. But I will say they've been looking for ether a hell of a lot longer than they've been looking for dark matter, and they never found any of that. And people that you respect did it. Tesla was looking for it. Fitzo was looking for it. Lorentz and all of them were looking for it. They couldn't find it.
When you say like looking for the ether, I thought that Tesla just assumed that the ether was true, and they were assuming that light was waves.
He assumed it's true because that was what they taught in the 30s. That's what Faraday thought. That's what Maxwell thought. And they were wrong. Maxwell had inconsistencies in his results that he couldn't understand. And Heaviside, the speed of light came barreling out of his equations. He just noticed that it happened to be close to the speed that was had already been measured by Ollie Romer, and astronomers had nailed that number down long before the electromagnetic theory caught up. And he said, that doesn't seem to be a coincidence. This light seems to be going the same as my electromagnetic waves. Maybe light is an electromagnetic wave. That was what Maxwell's insight was. But Heaviside knew that it wasn't working. The math wasn't working. Lorentz and Poincare, they were all trying to figure out, because what they didn't know was that the Lorentz transform was going to be the successful.
Where was just so I know, and out of curiosity, where exactly was the math not working out?
The math, he was finding that, let's see, the waves that were supposed to be spherical were oblong. He was finding length contraction in the magnetic field. Heaviside was. He was noticing that the field was changing in depth depending on motion. So he noticed that there were irregularities that did not square, and they could only be Lorenz's original idea was length contraction, but he couldn't explain the mechanism. He just said, what if? And it turns out that his what if was correct. He had the math. It's not the world's most complicated math. Minkowski space is flat.
But this was all based on the. But they were doing these measurements with interferometry, basically, correct? Or was there another method I'm not unaware of?
Lorenz saw the null result and said maybe it's due to length contraction, which is a real confusing point for people, because the people in the room, Michelson and Morley, didn't measure a length contraction because there wasn't one in their reference frame. They were moving with the experiment. If you were an astronaut sitting on the Parker Solar Probe, I suppose you could measure a length contraction in that room in the direction of motion. But no experiment in that room is going to detect that motion. That's what relativity is.
I mean,
so
obviously, in our worldview, there was no even need for length contraction, because if we don't assume that the Earth is moving, then we don't have to assume anything with our velocity of ether or lack thereof. And then we don't have to create this particle wave dynamic. I mean,
the other thing you like to pretend is that Michelson Morley was the only motivation for special relativity, when the truth is, I think there were 5. Aberration of starlight was one of them. Annual aberration of starlight. Something called the magnet and the conductor. There's a thought experiment with a magnet on a train, and that had nothing to do with the ether. That was just Einstein coming across this problem and solving it in his mind. There were 4 or 5 Fitz's experiment. There were 4 or 5 things that motivated special relativity, not just Michelson Morley, and certainly not an effort to prove that the Earth is moving. Einstein had bigger fish to fry. He was not concerned.
Well, one thing that we do agree on is that these guys were so indoctrinated that they were not trying to determine if the Earth was moving around the sun. They just assumed that it was true, even when the direct experimental evidence showed to the contrary. They then had to make a new mechanic like length contraction and relativity to explain this observation.
Actually, length contraction doesn't explain it. The problem is, as Robert pointed out, length contraction has no physical cause. And so Einstein solved that problem by stating through his first postulate that the speed of light is constant for every observer. That's why Michelson Morley got a null result. But my question to you, because I've gotten a lot of questions, my question to you is, you keep using the word indoctrinated, which I find to be a bit problematic. I don't like to think of myself as someone who's indoctrinated. Given the amount of research that I've done, given the amount of work that I've done. Can you tell me specifically who indoctrinated me?
Can I answer that? Troubling, can I go first and then please?
Sure. Yeah, 2 minutes.
Okay. I'm a little bit older than you, Professor Parks. I remember going into kindergarten at age 5, and I remember seeing this on the teacher's desk when I was age 5. And it wasn't probably till age 10 that I could probably refute it, but I got 5 years in, and my parents and my family and friends and teachers and fellow students would have laughed at me. So I was indoctrinated at age 5 if I wasn't indoctrinated sooner, because Toys R Us, when they were in business, sold this little thing you could put over the crib that had the little stars and the planets. So Professor Parks, I'm a little older than you are, but when you went into kindergarten, 1st grade, you would have seen this by the teacher's desk. The teacher wouldn't lie to you. So your indoctrination started at age 5 or 6. Am I wrong?
I don't remember what it was. What my kindergarten class. I do remember laughing at my kindergarten teacher. But I concede your point. I had a globe in my home when I was a kid. Yes, I was taught from a very early age that the Earth is a sphere. But More to the point, I then became a professional in the field. So where did who was indoctrinating me?
I'm really glad.
You
I'm really glad that
you
you asked this
explained it,
question.
Professor Parks. You explained it that you had a globe in your home.
So to keep long story short, the indoctrination does not get less as you get older. It actually gets more. So when you're born, you start just with the indoctrination of your parents. Whatever they know, whatever they think is true, they're going to indoctrinate into their children. It's just how it is. From there, we then get indoctrinated by our peers. It's known that once we hit like age 4 and 5 years old, we get a majority of our education from our friends that are around our same age. We learn from watching them. So they're all taught by their parents that the earth is a ball, because they were obviously taught as a kid that the earth was a ball. And they were taught that was true because these men in lab coats did the experiments and actually did the empirical scientific method. But when you actually dig into it and you have people at the top like George Ellis who say we're using philosophical models to choose what we're doing, and that admits that there's a range of models, then you have to ask yourself, wait a second, why wasn't I taught any of these other possibilities growing up? And the reason is, of course, because you're only spoon-fed one model for a particular reason. And they can make certain tweaks or changes to that model as time goes on, of course, when observations obviously force that. You can't blatantly lie, right? And for example, prime example, right, would be the redshift conversation, saying that everything is redshifting when you have a clear example of something not redshifting, right? Popular science says one thing, real science says something completely different. But we're all taught
funny that
the latter.
Funny you say that, because you knew that Andromeda was blue shifted. So somehow, but ultimately, you're not answering my question.
Yeah.
You're not answering my question. You're answering how I got indoctrinated. You're not answering who indoctrinated me.
Well, that would be everybody, right? I said your parents, which were indoctrinated by the teachers, which were indoctrinated by their education program, which were indoctrinated by the people at the top doing the peer review, who have a philosophical bias, like Hubble, like Einstein, like these named people that we are grown up taught as heroes of the scientific community. And when you actually find out that the astrophysicists are not even doing the scientific method, as Michio Kaku said, but we're taught in school that astronomy is science. Do you see where the problem is?
Is not an astrophysicist by any stretch. He's a particle physicist whose best work was done 35 years ago, and now he's a little better than a clown.
So let me get this straight. I want to be very clear about this, because this is a question I have asked many, many, many times, and I think I'm actually getting close to an answer with you. So you're telling me that the people who are responsible for the indoctrination are folks like Einstein and others of his ilk. Is that what you're telling me?
I would say that they would be good mouthpieces for. There's probably motivation. I'd say actually there's definitely motivation coming from even above them. So you can point to the Rockefeller Foundation, Rothschild Foundations that have admittedly poured millions of dollars into the universities, right? That people hold up to be holier than thou, right? As like the universities and the government are like somehow at odds, right? That's not how it works. So in any case, as far as
what
like
about before the Rothschilds and the Rockefellers?
Well, I don't even need to go back that far, right? I mean, they've been around since the 1700s.
Actually, you do, because
troubling. Can I just give another aspect to this? I think it's significant. I believe the Bible. Now, that doesn't have to be held by everyone, but there is another aspect of the indoctrination in the Bible too, very clearly. Satan deceived the whole world, and however that happens, I think I don't think anybody knows exactly how the devil could deceive the whole world at some point in time, but that's all I wanted to add, is that there is that other thought that goes through my head anyway when it comes to why do people believe some of these things and continue to teach them, and it is about a belief, really. I think that's what I'm learning anyway.
And I want to finish answering the question as like, You would say that I have to go back further than like the 1700s, 1800s. I actually wouldn't, because you can't verify any of the sources, right? You can't. There's no primary source for anything older than even the 1800s, right? There's no primary sources whatsoever. So
So Copernicus's book is somehow not a primary source. Galileo's dialogues
it's
are not a
actually
primary source.
it's admittedly not a primary source. Those are rewrites. We don't have the originals of anything anymore.
So in your mind, those have been altered.
I mean, we don't have the originals, so how can we say that we have the originals?
So you are discounting them because
Sure, yeah.
you are discounting them because you believe that they could potentially have been altered.
Absolutely. Stories.
By who?
That goes back into the story, right? So Rockefeller, Rothschild. Again, if we can literally stop the buck at them if we want to. Now, I don't know if it goes higher than that. This is the realm of speculation. But we know that the Rothschilds and the Rockefellers funded the education programs. We also know that they funded what we know about the medical field. So there's no question that they directly had motivation in what was being taught in these universities. They've also were quoted saying these really messed up things like, give me control of the money supply and I don't care who makes the laws. Another point, just adding to the character, poisoning the well, if you will. But in any case,
I would love to know where these your sources on that are. So this is the thing that I got frustrated on something else that was on another server, Earth Awakenings, I think. And I will attempt to not get as frustrated as I did there. Is that I am a professional in the field. I'm not trying to dick measure. I'm not talking about my PhD. I'm just simply stating that I am a professional in the field. That's just a matter of fact. So I know how it's done. And the idea that there is this overlord or this organization that we are paying attention to and basically just going in lockstep because that's just how we are taught. And indoctrination seems to indicate to me that we're not questioning it. That's not what is going on. We are constantly questioning what the accepted narrative. There are number of fields that are trying to show that relativity is not the greatest, is not what gravity is. So if we were indoctrinated, that wouldn't be happening. And the thing that I get frustrated is with lay people telling me how my profession is done. I hope you can understand why I would find that to be frustrating.
Very.
Because again, I'm not dick measuring. Cool. I have the experience in the field. You all don't. Mm-hmm. So it's my frustration comes from, we can disagree about, what the shape of the earth is. But the problem I have, the problem I have is when lay folks tell me how my profession is done. So, and what's it? I may seem like I'm running away, but I am actually planning on leaving in a few minutes. I've been here for a couple hours. So,
Professor Parks, you brought up before you go, and again, thank you for being here. You brought up Copernicus. Copernicus on the revolution of the heavenly spheres, May 1543, quoted Hermes Trismegistus, who was the father of alchemy, the precursor for modern chemistry. Alchemy says that lead can be turned into gold. Copernicus said in the book that you reference on the revolution of the heavenly spheres, and I quote, "In the middle of all, however, resides the sun, for in this most beautiful temple, who would place this lamp in any other or better place than this, where it can illuminate the whole universe all at once? Not unjustly, then, some call the sun the lamp of the cosmos, others its mind, and others still its governor. Trismegistus calls it a visible God." That is on the revolution of the heavenly spheres, May 1543. Copernicus supposedly died the same month. So you have Copernicus giving homage to Hermes Trismegistus, father of alchemy, and you could also say that quote tells you that Hermes Trismegistus worshipped the sun, a pagan sun worshiper.
Well said, Jim. Before we continue, I want to welcome Witsit Gets It and Andrew B to the show. Thank you guys so much for joining us.
What up, brother? Hopefully you can hear me.
Yeah, you
hey, Austin.
Well, I'm going to start first, if you don't mind, Austin. I'm going to say thank you very much for actually having the audience boot Brenda out, because that guy has nothing to add whatsoever and is psychologically deranged. I don't give a fuck if he comes on and says I'm a woman or not. No, you're not. And then on top of that, I have a question for anyone that is actually an astronomer or anything like that. How does the day-night cycle not change every 6 months? If
What do
it
you mean
according
by-
to the heliocentric model.
What do you mean by the day-night cycle?
He
6 months
thinks
from today.
it should flip-flop because the sun, the Earth will be on the other side of the sun. He doesn't understand the difference between the sidereal day and the solar day. And you gain 4 minutes a day until you're halfway spun around. The Earth does not rotate 365 times in a year. It rotates 366 times in a year, 366 and a quarter. So that's the simple answer. And all I can tell you is work it out with a tennis ball and a basketball. Call me back.
Yeah, I have no way to do that with a tennis ball and a basketball for an entire
Sure
year.
you do. You can take one rotates every 24 hours and the other rotates every 23 hours and 56 minutes.
I'll tell you what, I'm asking the question. Can you prove that with what you're explaining?
I'm telling you, work it out.
No, I'm asking you the question.
I did 366 rotations in a year versus the 365 that you expect. That accounts for halfway turned around, half the Earth and the other half coming back. That's it. That's all there is to it.
Back it up, boys.
Yeah, that sounds absolutely
Guess
horrible.
I gotta delete my channel.
Yep. Pack it up. Smoke them if you got them.
Hey, Robert.
Wait, Jim, real fast. Let me ask one question. I've been
Go
trying
ahead.
to get a lot of people to answer this question. I can't get anyone to answer this question. So, if the a geocentric model and a heliocentric model are kinematically and dynamically equivalent in validity, but the geocentric model wouldn't have a dark matter and dark energy problem, wouldn't that mean a geocentric model is significantly more viable?
Dark matter has nothing to do with the solar system. Zero,
What
zippo,
the
nothing
Okay,
to do with it.
buddy, that is not a good rebuttal. So
It doesn't play in the solar system. There's no discrepancy with general relativity anywhere in the solar system. It explains the precession of Mercury, the anomalous precession of Mercury. And your understanding, let me tell you, of gravitomagnetism is laughable. If you think it involves magnetism, it's an analogy. You don't know what lens throwing is. You talk a good game about relativity, but I heard you misuse the equivalence principle the other day. You don't know what the equivalence principle is, which is
hey, buddy, instead of you spiraling emotionally, try to pay attention to the question.
That's a direct question for an expert on relativity. What is the equivalence principle? It's the
Wait
basis.
up.
Hold on. You gotta give.
Okay, it's just that there's an equivalence between inertial and accelerative frames. Oh my God, you got me. So real fast though, the actual question was very simple, right? And surely Professor Parks wouldn't stamp that. You can't just say it's just about the solar system. If you claim we're going around the sun, then you have the solar system. That means that you're inside a galaxy.
Works out mathematically.
Bro, wait, calm down. That means that you're inside the Milky Way galaxy. So you don't get to just isolate the solar system and be like, oh, we don't want to talk about anything else. It's not 1500. We don't think the sun's in the middle of the universe anymore. We don't get to do that. We're not 5-year-olds. So
You do?
no, we don't. So you have to have if the Earth is not in the center, we have to have an accelerative expansion of the universe. Do you understand that?
It could be any other kind of they all have to meet with general relativity, but that doesn't mean it has to be expanding. It could be shrinking. There are other solutions.
Rob,
to the
1 second, real quick. Just because the other Rob has to go, Professor, and you had your hand raised, go ahead and say what you wanted to say.
Okay. Yeah. So real quick to answer your question, Austin, can you restate your question because I don't want to straw man it?
Yeah. If a geocentric model and a heliocentric model are kinematically and dynamically equivalent in validity, but a geocentric model doesn't have a dark energy and dark matter problem, then wouldn't that mean that a geocentric model is significantly more viable?
If you accept that question or that statement is factual, then you would then an honest scientist would have to look at the geocentric universe. However, the problem is I do not believe that the the neotychonic system is dynamically and kinematically the same. The question that I have that needs to be explained through in that book is, so if you have basically energy loss, if you have the Earth, for example, is measurably getting slower, it's measurably decelerating. And so we know the mechanism by which the energy is being dissipated for the Earth to being slowed down. Now, if you go with relational mechanics, what the geocentric model would say is that it's not the Earth slowing down, it's the entire universe slowing down. So what mechanism is there possible to rid the universe of its entire of that energy to explain the apparent rotation loss? And the last thing I will say is this is something that Robert pointed out, and I'm all about fairness. If you read the book that was given to me about relational mechanics, they actually do explain stellar parallax, and I haven't checked his math, but they have explained it, and it's really very, very straightforward in the sense that what they've done is that they have placed the Earth fixed at the center of the universe, and then everything revolves around the sun and the galaxies and all that. Everything else is in motion like it would be, but it's just going around the Earth. So if you add the fact that the stars are rotating around the sun, you would expect to see stellar parallax. So the question, but monologuing, ultimately, I disagree with the idea that it is dynamically the same. What my question is before I leave, and I don't expect anyone to answer it now, is energy loss. How can a geocentric universe explain the energy loss of things like tidal forces? And with that, it's been a pleasure. Real quick question to Tribune. Would you mind if I were to share this on my channel?
Go for it.
All right, sweet. Awesome. I would love to have a conversation with you again at some point. And yeah,
I like you, bro. We're cool.
Yeah,
absolutely.
Peace out.
Rob,
Later,
you're welcome anytime to the
Yeah,
open
thanks, Rob.
No problem.
Thank you, Professor Parks. Thank you.